Hello, everybody. Can anybody hear me? Cool. Who thinks I should make this presentation 5 minutes and we can all go to a coffee break? Okay, so I would like to start with a quote, which is like, I think it captures the essence of my presentation. And today we're going to be talking about IoT devices, and we're going to talking about like how attackers are trying to manipulate them and how do they gain profits out of them. So a little bit of information about myself. I graduated from Imperial College not so long ago. I then joined Kaspersky Lab, and since then I'm like a total master procrastinator. I try to delay things as much as possible. When I'm not doing that, I got interested in the economy of DDoS attacks, since we've seen more and more DDoS attacks happening in the last 2 years. We noticed that oh my God, actually people can profit from these DDoS attacks, and the attackers are financially motivated to launch these attacks. So I was talking about their economy, and I was also interested in how can I break these IoT devices in actually hardware and software in order to find vulnerabilities. Sometimes I try to put them back together, but it doesn't work all the time, so let's just get past that. I am part of the team which was founded in 2008, and it's called Global Research and Analysis Team. Some of you might have heard about it. We are actually focused on threat intelligence and research on major APT campaigns and infrastructure threats, banking threats, targeted attacks. Basically, everything that's hot nowadays, we are focused on that stuff. We are part of the big R&D group, part of Kaspersky Lab. So you might have known us you might have heard about us when we spoke about major APT campaigns we discovered, or my colleagues discovered, because I didn't join the team back then. So you might have heard about Red October. You might have heard about Epic and Satellite Turla. You might have heard about the Equation platform, which we announced 3 years ago. You might have heard about the Poseidon attack and the Lazarus, which was, of course, the Bangladeshi bank heist. So we are focused on most sophisticated threats. But today, we're not going to talk about this. We're going to talk about a really, really interesting piece of software, and like common malware. And does anybody know what malware is nicknamed the Great Worm? Anybody? Huh? So it was called the Morris worm. Anybody heard about the Morris worm? Yeah, some people, yeah. So 1988. It's like autumn 1988, and a lot of computers got infected by this worm. It was self-replicating, and it was attacking computers. Back then, people didn't have antivirus protections, so basically they got off guard. The only way to clean those computers was to power them down and restart them, because it wasn't persistent. So you had to restart them. Basically, people had to have clusters of computers where they would shut down all of them in the same time and then reboot them. If one infected computer would be connected by mistake to the other cluster of computers, it was game over. You had to restart doing that. So the cost of this malware were estimated to be from $100,000 to $1 million. So nobody knows about this stuff. But the man hours that were required to actually clean internet-connected computers back then, they were huge. So it was a lot of work back then. And what about now? Do we see the same things? Do we see the same problem? Computers getting infected, cars getting infected? Okay, I'm joking. Cars didn't get infected. But the problem still exists. We have modern operating systems. We have proper security controls, and yet a lot of computers get infected. And yet there's this eternal blue vulnerability, which was patched and is still exploited in the wild. So WannaCry is not the only example. There was this recent outbreak yesterday of another ransomware in Kiev in Ukraine and some computers in Russia. So this trend is still happening. And what's worrying is that more and more devices are still being added to the internet, are being connected. So business intelligence says they will estimate there are going to be like 30 billion devices. This young chap here at a conference not so long ago, which is Eric here, presented, and he said like there are going to be like 50 million devices, 15 billion devices connected to the internet by 2020. Well, he's a way smarter gentleman than I am, so I'll go with his number. 50 billion devices, that's huge. And then when we correlate this one with the fact that more and more DDoS attacks are happening, you can see a trend. And you can see as more devices are being added to the network, more and more DDoS attacks are happening because of money and because they're easy to get. So an interesting attack which happened here is Krebs on Security guy. I mean, I think you all know Krebs on Security. He exposed some hacker and he revealed his identity on his website. And what did the hacker do? He's used his DDoS platform and start attacking his website. Akamai said, okay, Krebs, we can't host your website anymore. Cloudflare said, we can't host your website anymore because the attack is so big. And then Google saved him. It was a happy ending story in the end. But then these attacks are still happening. And then the DNS attack was also important because it affected not only DIN itself, the DNS registrar, sorry, it's not registrar, DNS provider, but it affected Skype, it affected GitHub, it affected and other projects that were using the name servers. So the big problem is that we have more and more devices which are not properly secured being added to the network, being directly connected. So no proper controls. So meet Dahui. This shiny little camera produced by a Chinese manufacturer has an interesting default hard-coded password. Can anybody guess the username and the password for this camera? Go on. Sorry? Admin. Yeah, sure. It's not that, but you're close. Anybody else? No password. Yeah, that's also a possibility. Well, these guys decided to use this combination. Okay, I think like the idea of actually using hard-coded password and thinking like nobody will find out about that one. Like nobody will be able to find this one, and if there's a problem, we'll just log in. It's wrong. It's a flawed mentality. So people don't care about this. We as security experts, we are bashing producers. We are releasing publicly vulnerabilities. We are saying like, you should fix your products. You should fix everything. And vendors, what do vendors do? They're just looking for the money, and then they're selling. And what home users do? They're just looking for the cheapest device ever that does the job. So it's easy. Users, they don't care about security, and they will still buy these devices. And it's an endless cycle where users buy these devices which are exposed to security flaws, and vendors, they try to patch them, but they don't do a good job. So what do attackers do? They will try to find as many vulnerable devices as possible, and they will try to gain access to them. So they will not, most of the time, most of the attackers, they will not try to attack, like to deploy like sophisticated attacks, like 0 days or highly remote code execution buffer overflows. No, they will just go for the easier wins. If there's like a vulnerability publicly announced, they will adopt their attacks and their scans to scan for that vulnerability. And then if they catch like 1% of targets, that's totally okay. If they're scanning millions or billions of devices, that's totally fine. Even like a 0.1% success rate is acceptable. So what what some researchers presented not so long ago, they said that they found like 170 million devices in some major US cities, devices that are potentially vulnerable. So imagine overnight an attacker gaining access to 170 million devices. So you can do a lot of pretty crazy stuff with that thing. So our idea was to monitor those attacks. And we noticed that this trend is not a new trend. IoT security is not something new. It's something recurring. But people didn't talk about this. So there's these guys from SANS that are discussing about vulnerabilities in home small routers since 2010. There's my colleague here who discussed a vulnerability in a large Brazilian ISP, which delivered routers that were hijacked by the attackers. They changed the DNS settings, and thus they managed to hijack connections. Of course, in Brasilia, they were targeting banking websites, so they were mainly changing those websites. But there's no stop there. You can go further if you want. So, what did we do? We said, okay, attackers are targeting home users. Attackers are targeting IoT devices installed in home users. Why not deploy honeypots in home users' networks? Because if you deploy honeypot in an Amazon AWS network, then attackers got smart and they're actually not probing that network. Well, smart attackers. Some of them are actually doing that. But smart attackers are not probing ISP, like VPS networks or DigitalOcean or Amazon anymore, because it's a waste of their time. So instead, they're attacking home users because those ranges, those ASNs, are publicly available. So we deployed some of the honeypots. We started deploying honeypots in those ranges. Most of them are in Romania, is where I'm based at. But we also went a bit in the UK, and we got results. We got like a lot of results. What we have is like we have 14 million requests since 2 years ago. It's not much, but think about the fact that this is home networks and those IP addresses change most of the time. So attackers, they actually have to constantly change their scripts. So what did we see? The usual username brute force attacks, obviously. I mean, this is like common, and you can't change that much. We saw a Zyxel ROM0 attack, which was a vulnerability reported in 2014, and then it's still exploited today. We saw shell shock. When shell shock was announced, it was like crazy. We saw an Apache Strat attack, and we also saw recently a DLink, high-end DLink vulnerability being exploited. So I'm going to talk about these things in a moment. So what they were trying to do, they were trying to, for the ROM Pager, like Zyxel attack, they were trying to change the DNS settings because the Zyxel didn't expose, it wasn't running actual Linux flavor, it was running like a chopped down version, so they couldn't run commands on it. So they just relied on changing the DNS settings and then hijacking traffic. Shell shock, of course, the aim is to execute commands. Same for Apache Strat, and then for the D-Link is like total pwnage, like complete owning of this device. So, ROM Pager exploit. Basically, Zyxel, who produced the microchip for these routers, this is one of the Zyxel routers. This is how it looks like. It's a pretty old device. It's like from 2009, 2010. But this has a vulnerability such that you can access the configuration file. You can download that one without being authenticated. They implemented authentication for all other pages apart from the configuration file. So what attackers do, they just fetch the authentication file, log in with that username and password that is stored in the binary file, and then change the DNS settings. And this is done automatically. You don't even have to do anything. So they change DNS settings, and what are they doing? They're trying to change the ads. I'm sorry for this text is like not so visible, but basically they are replacing Google Ads with one of their own JavaScript codes. So this means that instead of showing an ad from Google, they're showing an ad from themselves. But they didn't stop here. They try to also force users to redirect users to install Netflix, which I don't know exactly what language this is. I think it's Dutch, or there might be Norwegian. I don't know exactly, but they're just trying to ask you to install Netflix. Well, I tried to click yes, which means ja, or ja, but it didn't work. So their attack it wasn't like such a well-designed web page. Then they're trying to invite you to invest in their Bitcoin, sorry, not Bitcoin, in their cryptocurrency coin. Like, okay, sure. I don't know exactly why would you invest in their coin, but whatever. Then they're trying to lure you to install browser add-ons, which is like, okay, first try, second try, third time with success. So because of Chrome settings, you can't actually display an iframe and you ask user to install add-ons from the iframe. So this Chrome extension basically can change all your data on all websites, and it's game over. If you install this one, it's game over. When I reported this one to Google, they had like 300 installs or something. So people actually click add extend, they actually click this one. So it's crazy. Then they try to serve you Flash exploits. This didn't work, this worked, and then of course it's a Trojanized Flash installer, and then they can own your computer in other ways. So people actually install these things. So mostly this was the thing with the Apache, with the ROM 0 in the DNS changer. The Apache vulnerability was discovered by Cisco on the 8th of March this year. Basically, it exploits the fact that you can execute code in one of the HTTP headers, and guess what? Immediately one day after, attackers started exploiting this vulnerability. So we got like 10,000 hits. This is how the content header, HTTP header, looks like. So it's kind of like crowded, like compressed here, but you can see like some commands. This is like a more a better version. Basically, you can see the commands. You can see the CNC server and the payload. So if you go I went to that CNC server. It's like in China, basically. They had multiple payloads for their attacks. So basically, for each attack they were generating a new payload, trying to fuzz it better, trying to use different encryption keys in order to avoid detection. So this is an interesting. I just found they opened a new server on a different port, and this was a new sample which already got downloaded by 1,000 infected clients. So you can see here on the 22nd of March, 6 days later, I went there, and you can see like multiple samples, and then like almost 3,000 clients that fetched this one. The RAR archives are actually list of IP addresses that the infected computers should scan next and infect next. So what was interesting about that is that they were trying to scan it directly. Well, one day I was checking my logs, and I was manually checking the logs, and then I noticed this one. This is like a pretty interesting case because those are FTP commands, which my Honeypot was fetching this kind of stuff. So my Honeypot was fetching these samples directly. So basically, whenever it saw vget, it was fetching this stuff. In the case of FTP commands, we had the problem. Because the FTP commands, my Honeypot said like, whoa, what should I do with this one? It didn't know how to handle this stuff. So the attackers noticed that the honeypots are automatically doing this stuff. So the attacker, they changed their attack. They, instead of executing commands directly, they echoed those commands and then executed the BAT file. So honeypot was like blindsided completely, and this was like pretty crazy stuff. So they were trying mostly to probe Chinese networks, mostly because the attackers were from China. So the ones attacking my honeypot were from China. They were trying to probe Chinese networks, and they were trying to probe mostly China, Korea, Japan, but also US and US, Taiwan, and India, which means that they were also looking for other targets as well, not restricting their searches only on China. So nowadays, they did something smarter. They noticed that they leave traces in their logs. So basically, instead of leaving the entire payload and the C2 server and the sample there, they're actually doing it in a two-step way. They're trying to execute echo commands, and then they will see if your router is vulnerable by echoing this command. And then on the second stage, they will actually deploy the payload. So this means that if you don't have like an interactive honeypot, then you won't miss the second stage request, second stage attack. You'll only see this kind of attacks in your logs. So basically, the honeypot needs to be smart enough in order to echo whatever they're requesting, and then you will see the second stage exploit. So the attackers got smarter. DLink is more interesting because it was discovered by the guys from Embeddy, and they said they had the same vulnerability as the Zyxel. So 7 years ago, the D-Link high-end routers, some of them, not all, they have the same vulnerability. You can search on Google what's there, and the interesting part is that they had the same vulnerability, and the problem is attacks started hitting the honeypots. So these attacks were not so harmful because attackers were probing for config files. They were just fetching the config file. I didn't see any second stage attacks regarding this vulnerability. Basically, I think they're just downloading config files, and later they will start mounting an attack. So basically, they're just probing currently. I didn't see any second stage login with using those credentials. But we can see on their website, 1 month later, they say D-Link has fixed one vulnerability, but the other two are still available. They're still not patched, and two other vulnerabilities are ignored by the developer. So well done, D-Link. At this point, I was like, oh my God, seriously, are you actually doing this stuff? So it's a non-vulnerability, but D-Link said, okay, we're gonna fix it later. It's not important for us. Check it out on their website. It's all there, and then you can see the entire thread. So we can't, of course, force any vendor to patch their devices immediately. But what we can do, we can try to see who's attacking them. So the Honeypot project is aimed to be running in a Docker container, to be as lightweight as possible, such that you can run it on any device, and you can deploy it on multiple platforms. You can also deploy it on this Raspberry Pi. So the aim of this thing is that you want to have this Raspberry Pi shipped into some client network, and then you can just let it there, and then it will collect attacks. So you can give it to friends, you can give it to some other people. They can install it in their home, and then they can have they can turn the home into a honeypot. Updating the honeypot code, because more and more attacks are being added, is done through GitHub. So basically, it's just a matter of pulling new changes and then updating the honeypot, restarting the web server, and this is it. The reason I chose Docker for this one is because I can run multiple honeypots. I can run a web honeypot, I can run a Mirai honeypot, I can run a SSH honeypot, I can run Kauri, I can run any honeypots I want on any ports, and it is compact. It can be run. It is basically a matter of spinning up a Docker machine, let it run, and then when you need to update, just pour it off, spin up a new Docker machine with the newest code, and then it runs on a Raspberry Pi. So portability-wise, is pretty good. Also, security-wise, is a little bit better because it's just enclosed in that container. So then you have the honeypots, and then what do you do with the logs? I set up a central collection log, basically an Elasticsearch server, and then the Elasticsearch server grabs all the logs from all honeypots. It's an aggregator, basically, grabs all the logs, and then it centralizes them in a place, and then with Kibana, you can see patterns, you can see, you can do whatever you want. The data is there. So this was the honeypot, and the aim of my honeypot is to be highly interactive. And we've seen, I was talking with some really smart persons last night, and they confirmed that also nowadays, if you're running a honeypot and it's not highly interactive, it means that you already lost the game. As I showed you before, it's really important for the honeypots to be highly interactive because attackers are doing second or third stage requests. First, they're probing to see if your device is infected. They're not revealing any C2s. They're not revealing any links. Then, if your device responds acceptable for them, or in a pattern for them, then they will launch the second attack. Also, I chose to run it in Python and also in Golang, mostly because I can emulate different attacks based on the requests I get. So I'm talking here about the HTTP honeypot, and I'm leveraging the fact that in an HTTP protocol, the client needs to send the request first. So based on the request I receive from the client, I can actually see, is he trying to exploit a Cisco or a D-Link vulnerability? Is he trying to exploit a ROM 0 / ROM -0, or he's trying to exploit a struts vulnerability? So based on that, I return the page he wants. For the Cisco, I return a Cisco vulnerable page. For the ROM 0, I return a vulnerable ROM 0 honeypot web page. For the struts, I echo whatever commands he wants to. So basically, you can make it interactive. What this works for HTTP mostly, and some SSH commands. So I'm focusing on tailored responses. But there's another issue. Like, you want to see which devices are actually being exploited. So you want to see what are the attackers doing and what credentials they're using. So it's a matter of where do you find a lot of credentials, on which cloud platform can you find a lot of leaked passwords? Can anybody know? Can anybody say? Sorry? Pastebin. Yeah? GitHub. Yeah, perfect. Well, I agree with you. But nowadays, thanks to Microsoft, I would say like a lot of whatever people are typing, a lot of telemetry is getting there. But you're right. On Pastebin, you can find like a lot of stuff. So what we did, I started searching using our an internal project we have in our group. I started searching Pastebin using Yara rules. So basically, we have a system where we can search for multiple repositories in our internal tool. And then we can have like virus repositories, we can have like clean file repositories, and we have like a Pastebin repositories. We have like robots scraping Pastebin, and then with that scraped content, we are able to search with Yara rules over pasties. So I don't know exactly if you can see here, I'm sorry for the small font. You can see I'm looking for, I wrote a Yara rule looking for leaked passwords. The idea is to have a database of leaked passwords in order to see which devices are currently being exploited. And then you can try to see, oh, this password matches this vulnerable devices made by this Chinese whatever producer. Okay, notify this guy to stop using this password or to properly secure his device. So with the adoption of IPv6, is gonna be is even more harder, and it's gonna be a chaos, I believe. Mostly because all these devices will be directly connected to the internet. Network address translation will not be used anymore, so basically they're trying to get rid of this stuff. More devices being directly connected to the internet, it means like more devices are being prone to be exploited. So this is a worrying trend. Also, new exploits will be discovered in the end, so that's something we can't stop it. So vendors will make mistakes, and then we can't stop it. So basically what we need to do, we need to monitor. If you think that, okay, this presentation was interesting, I would like to see, or I'd like to talk to you, well, please, let's get in touch. I mean, I'm here, I'm gonna be here for these 2 days. I'm happy to talk to you. I didn't release this project, I didn't open source this project yet, mostly because it's not ready to be open sourced yet, but I'm happy to share the code with whoever wants. If you want to play with it, to poke with it, sure, you can. I can give you like access, and then you can see what it is. Then the last question is like, okay, this will happen, but am I gonna be sleeping when the next DDoS attack happens? Well, hopefully not. Thank you very much.
Thank you very much, Dan. Thank you. That was really interesting.
Thank you.
So we will go with some questions for you. We will have some time, I think, a couple of minutes.
Hopefully, yeah.
Yeah.
I hope I was on time.
You was perfect on time. So we will start with this. What, in your opinion, are the most interesting techniques that attackers use?
So the most interesting one was the FTP technique, which basically it was like I was like, wow, this is amazing. Instead of like the normal attacks which I've seen, which were like 99% of the attacks, the FTP one, which completely blindsided my honeypot, was the most interesting one. And in terms of like scanning, I think just getting new exploits and then like adopting them that fast, it's pretty interesting to see and how they adapt to this market.
Yeah, and how you can always just be behind them.
Yeah, exactly.
So the Honeypot project, when will it start? You mentioned it, you have to talk to you. Anyone who is interested?
So the Honeypot project started 2 years ago.
Okay, it started
so we're collecting logs and attacks. If you want to run your Honeypot yourself and run the code you are doing, you can talk to me and then we can I can show you how it works.
Okay, great. So this is the time you got. What is your recommended antivirus solution for IoT?
I would say trainings for developers.
Yeah,
This is an important step. Like vendors should have proper trainings for their developers, for the ones developing their products, such that those people are actually writing software with security in mind. This is a worrying trend, mostly because I graduated from software engineering, and we did like at most 2 courses on security, like how
so
to
you
write
did have
secure.
any at least?
We did, yes, at least.
Yeah.
We did like how to write like secure C code, like what's a buffer overflow, what's like a remote code execution. Fine, but then this is not enough, and then I think security courses should be mandatory in high schools.
I couldn't agree more. Universities have totally screwed this up because they don't give any security education. Yeah, that's true.
Yeah,
so I could just, make an announcement. People might not know that the KTH in Stockholm is starting this year running a course in ethical hacking. So that is a good opportunity.
That's good.
Yeah.
Whatever, like, it's good.
So will you share the data, the aggregated data?
The aggregated raw data, unfortunately, I can't share it because there are like attacks from people in residential networks. So basically, there are attacks against their IP addresses, and there's like this all problems with privacy, and I can't share their IP addresses.
GDPR will have.
GDPR maybe GDPR, but I can share aggregated data, and I can share the payloads and all the patterns of the attacks. Those are public, and those are like generated by the attackers, and I don't care.
And you analyze and write reports about this and about your findings, or?
So currently, I'm as you see here, I generated like aggregate statistics and such. I don't write reports directly about this, but mostly about vulnerabilities and what we discover regarding these attacks. So I'm not writing reports directly about this, but I'm taking this data into consideration when I'm writing like a bigger report.
Next question. There's a lot of you got a lot of questions. So, what level of interaction is enabled on this Honeypot deployment? What transport is used for security telemetry?
So, actually, this is a technical question. So, the interaction, to answer the first question, the interaction level is like second stage interaction. Like, it can match echo commands, it can match vget commands, and also added some other matching trying to intercept the attackers. So basically, whenever the honeypot finds a matching wget command, for example, it will parse the URL, it will try to fetch immediately the sample, and then it will store it locally. And then it sends that payload to the aggregator. Because there's the case where the attackers are scanning, and the next day they power down their web server. So if you're not there at that moment, from that IP address, from that range they scanned, if you're not there fetching the sample, you will lose it. So the honeypot is trying to fetch and to fetch as many samples as possible. Also, when it's like echo commands, and you can see here the echo commands, it will try to echo as much as possible, but it can't. Sometimes it fails. It's not bulletproof. Sometimes it fails. Sometimes it's not echoing the expected output the attackers are looking for. In terms of transporting the telemetry from the users, I'm using SSH. Basically, passwordless authentication using public-private key cryptography, using SSH. So the honeypot node, I'm calling them like nodes or proxies, whatever. It's sending aggregated data it's sending telemetry data to the aggregator using SSH, and it's only configured to accept connecting to the aggregator using the specific hard-coded serial number. So if somebody tries to do like a man in the middle, or if somebody tries to take away my aggregator and then point out those honeypots to another node, it will fail the SSH authentication. Well, I think this is pretty secure, hopefully.
Hopefully, yeah. Well, at least you tried. So that will end the question and answer. And as a small token of our appreciation, we would like to provide you with a diploma certificate.
Thank you very much.
Thank you. And some reading on Swedish traditions. Thank you very much.
Thank you very much. Thank you very much, guys.